Welcome to PV Online. And today we're going to start our unit on stoichiometry by learning how to solve for molar mass. And all molar mass is that if you have a substance, some compound, chemical formula, we want to find out what is the mass of 1 mole. Now, the whole function of a mole is that atoms and molecules are so small that we have to have a lot of them in order for us to be able to measure them. The mole is a basic unit in chemistry, and it'll be very important to us. So we want to find the mass, the molar mass, and in order to do so, we have the periodic table. And in the periodic table, you can see that you have the atomic number here for aluminum, which is 13, the symbol, and then this number down here, that is called the molar mass. And it goes to 1/100 of a gram, and we're going to use that. And what that means is that if I have 1 mole of aluminum, it'll have a mass of 26.98 grams. So let's do this example of potassium chloride. We have potassium chloride and we need to know the molar mass. Elements that are metals are on the left-hand side, so potassium is over here, and you can see that it has a mass of 39.1. So I'm going to write down 39.10. I've got 1 potassium, I have 1 chloride. Nonmetals are on the right-hand side, so start focusing over here, and we can see that chlorine is this guy, and it has a mass of 35.45. So all I need to do is simply add the two masses together, and that'll tell me what 1 mole of potassium chloride will weigh. And so I get a mass of 74.55 grams of potassium chloride in every mole of potassium chloride. All right, on this next example, we have barium chloride. And do you notice what's different as far as its formula? And it has a subscript, this 2. And this 2 tells me that I need 2 chlorine atoms for every 1 barium. So barium is a metal, so it's over here on the left-hand side. It has a mass of 137.33, so let's write that down. I have 137.33 for my barium. So I've got 1 barium. I have 2 chlorines. The subscript 2 tells me I have 2 of those, so we're going to take 2 times, and chlorine is over here, a nonmetal, and it's 35.45. So I'm going to multiply the 35.45, and I'm going to add these 2 terms together. And when I add the 2 terms together, I get 208.23. And when you're doing your molar masses, remember to go to 1/100 of a gram. If I measured out 1 mole of barium chloride, it would have a mass of 208.23 grams. Now let's take a look at our third and final example, and this time we have calcium nitrate. And calcium nitrate is the most complex of these problems because in addition to having subscripts, we also have parentheses. So let's go ahead and start out with calcium since it's the first element that we encounter. And I simply have 1 calcium. There's no subscript next to it. Calcium is a metal, so it's over here. It's got a mass of 40.08. So calcium has a mass, and I've got just 1 calcium. So I've got 1 calcium with a mass of 40.08 grams per mole. Now let's take a look at the nitrogen. I have 2 nitrate polyatomic ions are going to be connected with my calcium, and each nitrate has 1 nitrogen. So that means I have to take this subscript and go, I've got 2 nitrates, or I'm sorry, I have 2 nitrogens. So I am going to take 2 nitrogens, and nitrogen has a molar mass of 14.01. Now, how many oxygens do I have? Remember, I have got 2 nitrates. Each nitrate has 3 oxygens. I have to double that subscript, which means I actually have 6 oxygens. So I'm going to take 6 oxygens, oops, and oxygen has a molar mass of 16. Once I find out the mass of each of the atoms, then I have to add them up, which gives me a molar mass of 164.10 grams per mole. Now on this assignment, you have the ability to check your answers, so make sure that you're doing it right. Good luck and we'll see you next time.